In 1977, two quiet machines left Earth on a journey that was never meant to become legendary. Their purpose was simple: travel to Jupiter and Saturn, collect data, and then drift into silence. No one at the time imagined they would go far beyond that, far beyond the planets, far beyond the original mission, and eventually far beyond the edge of the solar system itself. They were called Voyager 1 and Voyager 2. Built in an era when computers were measured in kilobytes and calculations were still verified with slide rules, these spacecraft were not designed for endurance on cosmic timescales. Their memory was smaller than a single modern image file. Their processors were weaker than the most basic digital devices we use today. Yet they were sent into the unknown with complete trust in engineering and physics alone. What made their journey possible was a rare planetary alignment. Jupiter, Saturn, Uranus, and Neptune aligned in such a way that a spacecraft could use each planet's gravity as a slingshot. This gravitational choreography, occurring only once every 175 years, turned a simple mission into something far greater: a guided path through the outer solar system without extra fuel. Voyager 1 launched shortly after its twin and quickly overtook it due to a faster trajectory. Within days, it captured something unforgettable: a distant image of Earth and the Moon together, suspended in a single pixel of light against a vast black background. That image was not scientific data alone. It was perspective. A reminder of how small and isolated our world truly is. As Voyager 1 approached Jupiter, it revealed a planet far more violent and complex than expected. Massive storms raged across its atmosphere, including the Great Red Spot, a centuries-old vortex larger than Earth itself. Its moons were not passive rocks but active worlds. Io erupted with intense volcanic activity, marking the first time in history that volcanism was observed beyond Earth. Europa, with its cracked icy surface, hinted at something even more profound beneath: a hidden ocean that may contain more water than all of Earth's seas combined. These discoveries reshaped planetary science. Jupiter was no longer just a gas giant. It was a dynamic system, almost like a miniature solar system of its own. After Jupiter, Voyager 1 moved toward Saturn. There, the planet revealed an even greater level of complexity. Its rings, once thought to be simple bands, were revealed as thousands of intricate structures, narrow and constantly shifting. New moons were discovered, each adding detail to Saturn's already crowded system. But the most important encounter was Titan. Wrapped in a thick orange atmosphere, Titan's surface was hidden from view. Yet its chemistry revealed something extraordinary: methane behaving like water does on Earth, existing in clouds, rain, and possibly lakes. It was the first hint that alien environments might host familiar processes in entirely different conditions. After Saturn, Voyager 1's path was forever altered. Its trajectory carried it out of the planetary plane, ending any chance of visiting other worlds. From that point forward, its mission changed. It was no longer a planetary explorer. It became a traveler heading toward the unknown boundary of the Sun's influence. Years passed as Voyager 1 moved farther from the Sun. Then, in 2012, something unprecedented happened. The spacecraft detected a sudden drop in solar particles and a sharp rise in cosmic radiation. It had crossed the heliopause, the boundary where the Sun's solar wind ends and interstellar space begins. This was not a gradual transition. It was sudden, almost like crossing an invisible wall. Inside the heliosphere, space is shaped by the Sun. Outside it, the galaxy takes control. For the first time, a human-made object had entered true interstellar space. What Voyager 1 discovered there changed everything again. Instead of emptiness, it found structure. Instead of silence, it detected a faint, persistent plasma oscillation, a subtle cosmic hum that continued for years. Scientists interpreted it as the vibration of interstellar particles, revealing the density of space between stars. The spacecraft also found that the interstellar magnetic field was stronger than expected. This suggested that our solar system is not drifting through empty void, but sitting inside a compressed bubble of space shaped by both the Sun and the surrounding galaxy. This bubble, called the heliosphere, acts as a shield. It reduces harmful cosmic radiation reaching Earth, creating a protective environment for life. Without it, our planet would be exposed to far more intense galactic forces. Even more surprising, Voyager's data helped confirm that the Sun exists within a larger region known as the local bubble, a vast cavity formed by ancient supernova explosions. This means Earth is not floating in random space, but inside a structure carved by the deaths of massive stars long before our solar system existed. Meanwhile, Voyager 1 itself continued to age. Its systems, designed for a few years of operation, kept functioning decades beyond expectation. It runs on less power than a simple household light bulb. Its commands take more than 20 hours to reach it, and another 20 hours to return. Yet it continues to respond. Its energy comes from decaying plutonium, slowly fading each year. To conserve power, instruments have been shut down one by one. Still, the spacecraft continues forward, carrying a golden record filled with sounds of Earth, human greetings, music, and images, an archive of a world it will likely never see again. At times, Voyager 1 has experienced communication failures. Once, it began sending distorted signals due to internal memory issues. Engineers had to carefully rewrite and relocate ancient code across decades-old systems. Each attempt required nearly a full day due to signal delay. After tense waiting, contact was restored. Voyager 2 faced similar challenges, including a near loss of orientation that briefly broke communication. In both cases, recovery depended on precision, patience, and the fragile resilience of outdated technology surviving extreme conditions. These moments reveal something deeper about the mission. Voyager is not just machinery. It is continuity. A fragile extension of human curiosity moving through a region no one had ever reached before. Beyond the heliopause, space is not empty. It is active, shaped by particles, magnetic fields, and waves that ripple across vast distances. The idea of silence in space begins to dissolve. Instead, there is environment, dynamic, structured, and constantly shifting. Voyager 1 is now moving toward the distant Oort cloud, a vast region filled with icy bodies that marks the outer boundary of the Sun's gravitational influence. It will take thousands of years just to begin passing through it, and tens of thousands more to leave it entirely. Long after its systems fail, Voyager will continue drifting. Silent, intact, and unchanged. A small object carrying humanity's presence into interstellar darkness. It will not encounter another civilization. It will not return home. But it will continue moving through space that is far from empty, space that carries structure, history, and forces we are only beginning to understand. And in that endless journey, Voyager 1 becomes something more than a spacecraft. It becomes a message without a destination, a marker of where we reached, and a reminder that even in the deepest darkness, humanity once looked outward and chose to explore.